how is it going? This video is going to be looking at another review of decimal division, particularly branching and long division. So at this point, we've done other strategies like the number lines or fractions, and we've discovered that we can use proportional relationships to make the division easier. So if our first problem is 62 hundredths divided by 4 hundredths, we know that we have 62 hundredths and we're breaking them into groups of 4 hundredths. And it's this 4 hundredths that makes it difficult for me to do the division because I'm dividing by decimals. This is less of an issue for me. However, when our divisor of 4 hundredths is a decimal, that makes it tricky. So I am going to take this and use a proportional relationship where if we multiply our 4 hundredths times 100 and our 62 hundredths times 100, we would get 62 divided by 4. Now, just a quick recap of why these proportions, why this works out is think if you had like $5 and you go into a store where everything costs $1. You can buy 5 items. But now you have 10 times as much money or 100 times as much money. So you have 50 bucks. But everything is also 10 times as expensive. So each item costs $10. You can still only buy 5 items. So even though we're technically doing 5 divided by 1 and 50 divided by 10, because these are a proportional relationship and they change by the same amount, you would get the same answer. So we're essentially manipulating our original expression to turn it into one that is going to be easier for us to solve. So I'm going to do 64 divided by 2 using long division first. 62 divided by 4. I don't know if that's exactly what I said. And we're going to start with our greatest place, which is the tens. So I know if I have 6 tens and I'm making groups of 4, I can make one group, and 1 times 4 is 4. So that leaves me with 2 tens. And we still have these 2 ones from up here, so I'm going to bring those down so I can now use them. Because I know that if I can't make any more groups of 10s, and I've dealt with all of that, I can regroup those 10s into 1s. So I took my 2 remaining 10s, and I thought of them like they were 21s, plus the 2 that we already had from our original dividend, from our original dividend. So now I know if I have 22 ones, I can make 5 groups of 4, and that would use 20 of those ones. And I'm left with 2 ones. So I've dealt with all my ones, but I still haven't gotten to a 0. So I'm going to keep working until I get to a 0 or until I get to a repeating decimal. So I know 2 ones, though, are equivalent to 20 tenths. So I'm going to show that by putting a decimal point there and then writing this as 2.0 because that to me looks like a 20 that ends in the tens place. And so I know that if I have 20 tenths, I can do 20 divided by 4 and get 5. But I need to make sure that those are 20 tenths, so this here has to be 5 tenths as well. So I'm going to keep my decimal point there. So if we were to line up where our decimal point was all the way down here, you would see that it is lined up. And we know 4 times 5 is 20. And when I subtract, I get 0. So my answer is 15 and 5 tenths. Now, I'm going to use branching to check myself on this one because it's a little bit more visual. This long division is algorithm process based, and so you just need to follow the steps. But if we do branching, it's a little bit more conceptual, and we can see what we have and how we can manipulate it. So we have 62 that we are dividing into 4. So I know that if I pull out a 40 first, I would be left with a 22. And I chose this 40 because I know my tens really well, and I know 40 divided by 4 is 10. So I'm left with this 22, and I know 4 doesn't go into 22 evenly because if I count my multiples of 4, that's 4, 8, 12, 16, 20, 24. So I skip over that, but I could use 20 because 20 divided by 4 is 5. And now I'm left with 2 ones. And so 2 ones divided by 4 is a little bit tricky, but if I think of those like they are 20 tenths, And again, 20 as a tenths as a fraction is equal to 2. But 20 tenths divided by 4 does equal 5 tenths. And I love, love, love this place value language there because it makes it really easy for me to tell the value of this 5. I don't have to worry about swooping decimal points or this, like, I need to remember this trick or that trick. I'm keeping the value of those numbers intact when I use this strategy. So now I know that I have 10, 5, and 5 tenths. So that is 15 and 5 tenths. So there you go. 62 hundredths divided by 4 hundredths is 15 and 5 hundredths, or 15 and a half. Now, another one that might be a little bit more challenging looking than this is 6 and 54 hundredths divided by 1 and 2 tenths. So what's going to be a little bit tricky about this one is if you look over here, we have 2 decimal places, and so you might be tempted to use a proportional relationship of 100. But if we did that, I would be dividing 654 by 120. And dividing by 120 seems unnecessarily complicated, especially when you look up here. We essentially ignored the decimal point when we did long division, so I might as well keep my divisor as small as possible. So when I'm picking my proportional relationship, I'm going to be focusing on the divisor and turning that into a whole number. So to do that, I need to move it over one place, so that means times 10. So to my dividend, I need to do the same thing, times 10. So our new equation that is going to be easier is 65 and 4 tenths divided by 12. So again, I will do long division first, 65 and 4 tenths divided by 12. So I know 12 doesn't go into 6, but 12 does go into 65. I know 12 times 5 is 60, and that leaves me with 5 ones. So I'm going to bring my decimal points, keep those all nice and lined up. So I have 5 ones left, but I still have these 4 tenths. So 5 ones and 4 tenths is equivalent to 54 tenths. And that's useful because if I have 54 tenths, I can do 54 divided by 12. And I know 12 goes into 54 4 times because that would be 48 tenths. And now when I subtract, I am left with 6 tenths. So if we're keeping track of our place value, up here we started with our tens. We said that there were 0 of them. So then we went to our ones. We took care of that with the 60. And now we've taken care of the tenths. So knowing my place value, since I still have 6 tenths, I might as well break those into smaller pieces, which would be hundredths. So 6 tenths is equivalent to 60 hundredths. And I know that 12 times 5 is 60. And because those are hundredths, we can write it like that. So here, and then we get our answer of 0. So you can see that by using our knowledge of place value and coming up with equivalent decimals, knowing that like 6 tenths equals 60 hundredths, it's a way of thinking about these values in a way that's easier to divide. Because 6 tenths divided by 12 is a little bit more difficult than 60 divided by 12. So let's look at branching just to check ourselves. So we are still going to start out with our 65 and 4 tenths, and we're making groups of 12. So if I need to, I can write out my multiples of 12 if I find that to be helpful. So I have those multiples there. This is multiple 1, 2, 3, 4, 5, 6. So in here, I notice that we have a 60, and then 65 and 4 tenths minus 60 would leave me with 5, and 4 tenths. So 60 divided by 12 is 5, and I know that because it's right here. And then again, I'm left with 5 and 4 tenths. So I'm going to think of this as 54 tenths. So that way I can regroup it or convert this into an equivalent decimal, something that's easier for me to divide. Now, looking back at my list of multiples, I'll grab a different color, I know that 48 is enough to get us there, and then that would leave us with 6 tenths remaining. So these are 48 tenths. 48 divided by 12 is 4 tenths. And so I'm going to be very, very careful when I branch to keep this place value language because that tells me how much that 4 is actually worth. So, I did not leave myself enough room on the side here. So I'm going to quick drag this over. Okay, so now we are on to these 6 tenths I know are equal to 60 hundredths. And 60 hundredths divided by 12 is 5 hundredths. So again, I'm keeping those place value words so that way when I put my answer together, I have 5 ones, 4 tenths, and 5 hundredths. So if we look, this answer matches this answer, we should be pretty good to go. So either of these strategies works. You're using the same type of conceptual understanding that if I am working from my greatest place to my least place, and I can't make a group of 12 for my divisor, then I can regroup those bigger places into smaller pieces. It's like you're taking pizzas and cutting them into smaller pieces to be able to share more evenly.